The Industrial Revolution stands among the most profound turning points in human history. At its core, it describes the rapid transformation of societies, from rural, agrarian, handcraft economies into industrial, mechanized ones. That transformation unfolded in waves: new energy sources, factory production, machine tools, urbanization, and sweeping social change. The first and subsequent industrial revolutions were characterized by revolutions in energy production, communication, and transportation. But to understand why the Industrial Revolution was possible and what its full consequences were, we need to look deeper, tracing the long arc of toolmaking, trade, institutional change, and technological breakthroughs. In this talk, I'll move chronologically from the deep origins of tool use through early machine tools and institutional shifts into the first and second industrial revolutions, then into later phases of industrial and technological change. Along the way, I'll highlight key innovations, benefits, and costs, and show how this journey shaped the modern world we live in. Between 3.3 and 2.6 million years ago in East Africa, early hominins began to chip rocks to create sharp flakes for cutting and scraping. Those tools opened new dietary and material possibilities, cutting carcasses, working hides, shaping wood, and over time helped drive brain dexterity and social learning. By 1.7 to 1.5 million years ago, more refined large cutting tools like hand axes emerged, improving tasks like butchering and woodworking. These imply more advanced planning and skill. Around 400,000 years ago, wooden spears and hafted points or stones attached to handles appear, enabling hunting at distance and more efficient gathering strategies. Later in the Paleolithic, people began to make tools from bone, antler, ivory, and combinations of materials, making what we refer to as composite tools. Awls, needles, fishing implements, sewing, shelters, and fine carving all followed. Symbolic tools like ornaments, art, ritual objects, and division of labor in specialized crafts emerged, enriching human life beyond mere survival. Mastery of fire was itself a powerful tool. Cooking, heat treatment of stone, protection, illumination combined to rewrite human ecology and physiology. From cooked diets to ovens, humans altered daily life, new social patterns, extended work and social hours, new cooking tools. Eventually metallurgy followed. Smelting and forging metals, first copper, then bronze and iron, revolutionized tools, weapons, infrastructure, and capacity for large-scale construction. Around 10,000 to 8,000 BCE, in several world regions like the Fertile Crescent and East Asia, humans adopted domestication and farming. Tools for planting, harvesting, plowing, irrigation, and storage emerged. With settled agriculture came food surpluses, population growth, permanent settlements, trade, specialization, social stratification, and institutional complexity. The Bronze Age, between 3000 and 2000 BCE, and then the Iron Age, introduced better metal tools, stronger plows, building tools, and weapons. These advances sustained and expanded empires, cities, and infrastructure. In sum, all of these developments, from stone flake to plow to smelted iron, laid the foundations for what would become the machine-based industrial world. Without this deep background, an industrial revolution would have had little to build on. Before the famed steam engines and textile mills, several innovations and institutions set the stage. Machine tools are machines that shape, cut, or modify hard materials like metal through controlled, repeatable action. This brought about the development of lathes, milling machines, boring machines, and screw-cutting lathes. The lathe is a machine turning a workpiece against a cutting tool and is one of the oldest machine tools. A simple form appeared in ancient Egypt around 1300 BCE, used with manual drive. Between 700 BCE and 400 CE, Greeks, Romans, and Egyptians used wooden and corded lathes for symmetry in objects. In the medieval period between 500 and 1500 CE, foot-powered or pedal-driven or rope-driven lathes improved operations, though still limited in precision. During the Renaissance and early modern era, Thinkers like Leonardo da Vinci sketched designs for screw-cutting lathes, lead screws, tool slides, change gears, internal grinders, ideas that would later become real machine tools. In the 16th to 17th centuries, spring pole and treadle lathes gained use, especially in clock and watchmaking. Greater precision, repeatability, and small part machining emerged. The Silk Road, circa 130 BCE to 1453 CE, connected East Asia, Central Asia, the Middle East, and Europe. It was a conduit for goods and ideas, technologies, religious beliefs, and institutional forms. In 1453, the Ottoman conquest of Constantinople disrupted Silk Road continuity, encouraging European powers to seek maritime routes to Asia, setting in motion the age of discovery and colonial expansion. In medieval England, the City of London's governance system began to take form, which a local commune organized in 1141, formalized by 1215. This body of merchants and businessmen gradually evolved toward a quasi-corporate, self-governing structure. In 1215, the Magna Carta affirmed certain liberties, including trade liberties, granting the City of London autonomy from the Crown, a precedent for limited state, corporate, and commercial freedom. By the 16th century, European maritime ventures, especially Spanish and Portuguese colonization, starting in 1501, began to supply raw materials, new markets, and trade networks to feed emerging manufacturing interests. In 1540, the introduction of a water-powered cannon boring mill in England, Sussex Weald, mechanized the boring of large metal parts, useful for both weaponry and future steam engine cylinders. Meanwhile, the establishment of organizations like the Dutch East India Company in 1602 pioneered the modern joint stock model, pooling capital, limiting personal liability, and promoting large-scale enterprise. These machines, institutions, and trade networks were the scaffolding upon which the industrial revolutions would build. The first industrial revolution is often dated from the mid to late 18th century in Britain. It marks the real onset of mechanized production on a large scale. Around 1764, James Hargreaves invented the spinning jenny, allowing one worker to spin multiple spindles of thread. In parallel, James Watt improved Newcomen's steam engine patented in 1769 by adding a separate condenser, making steam power much more efficient and widely usable in industry. Richard Arkwright integrated steam power into textile mills and developed the factory system. In 1785, Edmund Cartwright patented a power loom to mechanize weaving. In 1779, Samuel Crompton's spinning mule combined features of earlier machines, improving thread quality and flexibility. In the United States, Samuel Slater brought British textile technology to Rhode Island in 1793, starting the U.S. textile industry. Also in 1793, Eli Whitney's cotton gin mechanized seed removal in cotton, accelerating the cotton industry, though with morally problematic social consequences. In the 1830s to 1840s, railways and steamships proliferated. In 1830, the Liverpool-Manchester Railway opened in England. Telegraphy emerged mid-19th century, transforming communication. The factory system and machine tools improved in precision, and the concept of interchangeable parts advanced manufacturing. Productivity and output exploded. Mass production made goods more affordable, raising standards of living for many. The rise of coal as a fuel in iron production scaled rapidly, including by combining new processes like coke smelting in ironworks. Populations shifted en masse from countryside to cities, intensifying urbanization. In Britain, by 1850, over half the population lived in towns, versus 15% in 1750, according to some estimates. Living conditions in early industrial cities were often dire, creating problems of overcrowding, poor sanitation, pollution, and disease. Labor conditions could be brutal, evidenced by long hours, low pay, child labor, and unsafe environments. Growing inequality and social tensions led to labor movements, unions, and legislative reforms like child labor laws and public health regulations. By the mid-19th century, industrialization had enveloped much of Western Europe and parts of America, though some regions would industrialize later. Also known as the Technological Revolution, this phase introduced electricity, mass production, new materials, communication, and transport breakthroughs. Electrification and electric power networks emerged. The Pearl Street Power Station, built by Thomas Edison in 1882, was among the first central power plants. The telephone was patented by Alexander Graham Bell in 1876. Radio and wireless telephony, developed by Guglielmo Marconi, pioneered long-distance radio in the 1890s, allowing Reginald Fessenden to make some of the earliest audio broadcasts in 1900 and 1906. The internal combustion engine, automobiles, and petroleum-based fuel systems gained momentum. The assembly line sparked mass production. Henry Ford famously introduced moving assembly methods in 1913 to produce the Model T, first made in 1908. On December 17, 1903, the Wright brothers achieved the first sustained powered flight. Mass production and standardization made consumer goods more accessible and affordable. Communication and transport, telegraph, telephone, railroads, steamships shrank time and space, enabling global trade, corporate networks, and integration. New industries, chemicals, electrical goods, automobiles, aviation reshaped economies. The gap between industrialized nations and non-industrial ones widened, fueling imperialism, colonial expansion, and dependency. Social, labor, regulatory, and political systems evolved in response, including safety laws, labor rights, antitrust, welfare policies, and national planning. The Second Industrial Revolution thus laid the foundations for the 20th century's technological leaps. In the late 19th and early 20th centuries, electric light, motors, railways, subways, and electric trams spread across cities. Radio and early telecom networks matured. Mid-20th century saw the emergence of mainframe computing, early digital electronics, and telecommunications, often called the Third Industrial Revolution or the Digital Revolution. In 1964, Japan introduced the Shinkansen, or bullet train, a hallmark of modern high-speed rail. Solar cell development began mid-20th century, most notably at Bell Labs in 1954. Energy crises in the 1970s spurred research in solar, wind, geothermal sources. In 1977, the U.S. created the Department of Energy to oversee energy policy and technology. The late 20th century saw the rise of the Internet and the World Wide Web. In 1989, Tim Berners-Lee proposed linking hypertext documents into a global network. Into the 21st century, we see emerging paradigms like the Fourth Industrial Revolution, including robotics, AI, the Internet of Things, biotech, and cyber-physical systems. The growing dependency on fossil fuels, environmental pollution, climate change, resource depletion, and social inequality pose critical tests. Oil price shocks like the record $147 per barrel mark in 2008 reflect global energy volatility. International agreements try to address climate change via green transitions. Technological disruption, job polarization, and calls for just transitions pressure policymakers and societies. The story of the Industrial Revolution is not just a century of steam and factories, it's the long sweep from stone flake to silicon. Only by seeing how tool-making, institutions, trade, energy, and ideas built upon one another can we appreciate how and why the modern industrial order emerged. The Industrial Revolution unleashed vast gains in productivity, material abundance, life expectancy, and human potential. But it also generated deep challenges: urban squalor, worker exploitation, inequality, environmental degradation, problems that we still wrestle with today. In understanding this history, we can better understand our present and consider how to steer the next industrial transformations toward more equitable and sustainable paths.